Hello everyone, welcome to session 18 of Statistics and Analytics Lab. We are in Unit 3, that is measure of location and dispersion. Now in this session we are going to look at the definition of skewness and kurtosis, importance of skewness, importance of kurtosis, then difference between skewness and kurtosis. Then lastly we are going to see how we can find the skewness and kurtosis in Excel. Now, first of all, what is skewness? Skewness is the measure of symmetry, or more precisely, the lack of symmetry. That means if you are a set of data values, ಆ data values ಅವುಗಳ mean ಇಂದ ಒಂದೇ ರೀತಿಯಲ್ಲಿ distribute ಆಗಿದೆಯಾ on the left hand side as well as on the right hand side. ಅದರ measure ಅನ್ನು ಕೊಡುವುದೇ skewness. A distribution or a data set is said to be symmetric if it looks same to the left and to the right of its central point. ಯಾವುದೇ ಡೇಟಾ ಸೆಟ್ ಅನ್ನು ನಾವು ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಇಸ್ ಸಿಮೆಟ್ರಿಕ್ ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ಸೆಂಟ್ರಲ್ ಪಾಯಿಂಟ್ ಇಂದ ಸೆಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರುವಂತಹ ಎಲ್ಲಾ ಡೇಟಾ ವ್ಯಾಲ್ಯೂಸ್ ಒಂದೇ ರೀತಿಯಲ್ಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿರಬೇಕು. Skewness can be measured using this formula in Excel. Equal to ಅಂತ ಟೈಪ್ ಮಾಡಿ ಸ್ಕ್ಯೂ ಅಂತ ಕೊಟ್ಟು ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಡೇಟಾ ರೇಂಜ್ ಅನ್ನು ಸೆಲೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸ್ಕ್ಯೂನೆಸ್ ಸಿಗುತ್ತೆ. The skewness can be positive, can be negative, or it can be zero. Skewness zero ಇದ್ರೆ we call that distribution as normal distribution. Now let us consider one example. Let us consider the data set of heights of all high school students. ಹೇಗಿರುತ್ತೆ data set? The heights may range between 0.9 meter to 2.1 meter. Now let us see data ಒಂದೆಲ್ಲ ನಾವು ಒಂದು ಗ್ರಾಫ್ ಯೂಸ್ ಮಾಡಿ ಪ್ಲಾಟ್ ಮಾಡುವ. Let us take the interval of heights as 0.2. Now how does the graph might look? Let us see. Heights ಅನ್ನು ನಾನು 0.2 ಇದು interval ಅಲ್ಲಿ ಪ್ಲಾಟ್ ಮಾಡಿದ್ರೆ the graph might look like this. You just observe this graph. Where is the central point? It's here. This is, you call this center point as a mean. This is a balancing point, I can say. ಈಗ ನೀವು ಇಡೀ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, ಈ ಗ್ರಾಫ್ ಅನ್ನು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, ಈ ಗ್ರಾಫ್ ಸೆಂಟ್ರಲ್ ಪಾಯಿಂಟ್ ಇದ್ದು ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಮತ್ತೆ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಒಂದೇ ತರ ಕಾಣಿಸ್ತಾ ಇದೆ. ಐ ಕ್ಯಾನ್ ಸೇ ದಟ್ ಇಟ್ ಇಸ್ ಸಿಮೆಟ್ರಿಕ್ ಟು ದ ಲೆಫ್ಟ್ ಅಂಡ್ ರೈಟ್ ಆಫ್ ದ ಸೆಂಟ್ರಲ್ ಪಾಯಿಂಟ್ 1.5 or the mean. So this type of distribution, you call it as the normal distribution. Graph ಅಥವಾ distribution central point ಅಥವಾ mean ಇದ್ದು ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಮತ್ತೆ ರೈಟ್ ಸೈಡ್ ಇಂದ ಸೇಮ್ ಇದ್ರೆ ಅದಕ್ಕೆ ನಾವು ನಾರ್ಮಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಅಂತ ಕರಿತೇವೆ. ಬಟ್ ಯಾವುದೇ ನೀವು ಡೇಟಾ ಸೆಟ್ ತಗೊಂಡ್ರು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಯಾವಾಗ್ಲೂ ಹೀಗೆ ಇರ್ತದಾ? ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಯಾವಾಗ್ಲೂ ನಾರ್ಮಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಆಗೇ ಇರ್ತದಾ? Let us see that. Now one more thing, for the normal distribution, mean, mode and median are always at the same point. Now let us see for all the data set whether the distribution will be always normal, whether the graph will be symmetric on the left side and the right side of this central value. Now for that, to look at that, let us consider one more example. Let us consider the monthly income of people in a region. ಈ ಡೇಟಾ ಸೆಟ್ ತಗೊಂಡ್ರೆ ಡೇಟಾ ವ್ಯಾಲ್ಯೂಸ್ ಹೇಗೆ ವೇರಿ ಆಗ್ಬೋದು? ಪೀಪಲ್ ಇದು ಇನ್ಕಮ್ ಪ್ರೊಬ್ಯಾಬ್ಲಿ ಇಟ್ ಮೇ ಬಿ ಇನ್ ಬಿಟ್ವೀನ್ 10,000 ಇಂದ 1 lakh ಒಳಗೆ ಇದೆ ಅಂತ ನಾವು ಅಸ್ಯೂಮ್ ಮಾಡಿದ್ರೆ ಅದರ ಗ್ರಾಫ್ ಡೇಟಾ ವ್ಯಾಲ್ಯೂಸ್ ಇದು ಗ್ರಾಫ್ ಪ್ಲಾಟ್ ಮಾಡಿದ್ರೆ ಗ್ರಾಫ್ ಹೇಗೆ ಕಾಣಿಸಬಹುದು? Let us see. The graph might look like this. Now, let us analyze this graph. What does this graph say? This is the mean. This is a central point. 50,000 is a mean. ಹೆಚ್ಚು ಜನರು ಯಾವ ರೇಂಜ್ ಅಲ್ಲಿ ಸ್ಯಾಲರಿ ಪಡ್ಕೊಳ್ತಾರೆ? ಜಾಸ್ತಿ ಜನರಿಗೆ ಸ್ಯಾಲರಿ 20,000 ಮತ್ತೆ 50,000 ಒಳಗೆ ಇದೆ. 10,000ಕ್ಕಿಂತ ಕಡಿಮೆ ಸ್ಯಾಲರಿ ಇರುವ ಜನರು ಕಡಿಮೆ ಇರ್ತಾರೆ. ಮತ್ತೆ 1,00,000ಕ್ಕಿಂತ ಜಾಸ್ತಿ ಸ್ಯಾಲರಿ ಇರುವ ಜನರು ಕೂಡ ಕಡಿಮೆ ಇರ್ತಾರೆ. That all these things we can analyze from the graph. Also, one more thing what we can say is, if you look at the graph, is the graph symmetric? Is it looking same on the left hand side and right hand side of the mean? Is it looking same? No, right? You can see a long tail on the positive side of the mean. Positive side and the right side of the mean, right? This kind of distribution, you call it as positively skewed distribution. Distribution alli long tail mean iddu data set idde mean irtade adra right side ಅಥವಾ positive side alli idre, you call that distribution as positively skewed distribution. ಇಲ್ಲಿ ನಾವು ಡೇಟಾ ವ್ಯಾಲ್ಯೂಸ್ ಎಲ್ಲ ಮೀನಿನ ನಂತರ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗಿದೆ. ಜಾಸ್ತಿ ಡೇಟಾ ವ್ಯಾಲ್ಯೂಸ್ ಮೀನ್ ನಂತರ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ಬೋದು. Now let us consider one more example. Let us consider the marks obtained by students in a test. Marks may vary between 0 to 100. Let us plot the graph. ಇದಕ್ಕೆ ಗ್ರಾಫ್ ಹೇಗೆ ಕಾಣಬಹುದು? Let us see. The graph might look like this. What is the meaning of this? 10ಕ್ಕಿಂತ 20ಕ್ಕಿಂತ ಕಡಿಮೆ ಮಾರ್ಕ್ಸ್ ಇರುವವರು ತುಂಬಾ ಕಡಿಮೆ ಇದ್ದಾರೆ. 90ಕ್ಕಿಂತ ಜಾಸ್ತಿ ಮಾರ್ಕ್ಸ್ ತಗೊಂಡವರು ಕೂಡ ತುಂಬಾ ಕಡಿಮೆ ಇದ್ದಾರೆ. Where is the mean? Mean is this average. ಜಾಸ್ತಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಯಾವ ರೇಂಜ್ ಅಲ್ಲಿ ಮಾರ್ಕ್ಸ್ ತಗೊಂಡಿದ್ದಾರೆ? This is a mean. ಜಾಸ್ತಿ ಮಾರ್ಕ್ಸ್ ತಗೊಂಡದ್ದು ಸ್ಟೂಡೆಂಟ್ಸ್ 80ರಿಂದ 60ರಿಂದ 80ರ ಒಳಗೆ, ಈ ರೇಂಜ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಜನರು ಮಾರ್ಕ್ಸ್ ತೆಗಿತಾರೆ. ಕಡಿಮೆ ಮಾರ್ಕ್ಸ್ 10ಕ್ಕಿಂತ ಕಡಿಮೆ ತೆಗೆಯುವವರು ಸ್ವಲ್ಪ ಜನ, 90ಕ್ಕಿಂತ ಜಾಸ್ತಿ ತಗೊಳ್ಳೋರು ಕೂಡ ಸ್ವಲ್ಪ ಜನ. And also you observe here also the graph is not symmetrically distributed on both sides, on the left hand side and the right hand side of the mean. How it is? Where you can see the tail? You can see the tail here. That is on the left side of the mean. That is on the negative side of the mean. This kind of distribution, you call it as negatively skewed distribution. Andre data values ಎಲ್ಲ ಜಾಸ್ತಿ mean ಇದ್ದು ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಡಿಸ್ಪರ್ಸ್ ಆಗಿದೆ ಅಂತ ಅರ್ಥ. Now, you can see two pictures here. This picture, the second one, shows the positively skewed distribution because the tail is on the positive side or right side of the mean. And the first picture shows the negatively skewed distribution because the tail is on the left side of the mean. It's on the negative side of the mean. Now, as you can see from the graph, from the picture, in a positively skewed distribution, mean is the largest value, then comes the median, then the smallest is mode. So for a positively skewed distribution, mean is greater than median, which is greater than mode. And also you observe from the first picture that in a negatively skewed distribution, mean is the smallest, then comes median, and then comes the mode. Now, this is the scale of skewness. Skewness, if it is absolute value of skewness is in between 0 to 0.5, skewness iddu value 0 ದಿಂದ 0.5 ಒಳಗೆ ಇದ್ರೆ, we say that that distribution is less skewed ಅಥವಾ low skewed ಅಂತ ಹೇಳ್ತೇವೆ. ಅದೇ ಸ್ಕ್ಯೂನೆಸ್ ಇದ್ದು ವ್ಯಾಲ್ಯೂ absolute value 0.5 ಮತ್ತೆ 1 ಇದ್ದು ಒಳಗೆ ಇದ್ರೆ, we call that distribution as moderately skewed distribution. If at all the value of skewness is greater than 1, absolute value of skewness is greater than 1, then we say that that distribution is highly skewed distribution. Next comes kurtosis. Now, what is kurtosis? Kurtosis is the measure whether the data are heavy-tailed or light-tailed relative to a normal distribution. Or in simple words, I can say that kurtosis is a measure of peakedness or flatness of a distribution. Distribution peak ಆಗಿದೆಯಾ ಅಥವಾ distribution curve flat ಆಗಿದೆಯಾ ಅನ್ನೋದರ measure ಅನ್ನು ಕೊಡುವುದೇ kurtosis. Kurtosis ಅನ್ನು measure ಮಾಡಲಿಕ್ಕೆ Excel ಅಲ್ಲಿ we have this formula equal to kurt, and within the brackets you select the range of data of which you want to calculate the kurtosis. Now, for a normal distribution, value of kurtosis is 3. If kurtosis is greater than 3, then the distribution is pointier, and the kurtosis is less than 3, then you say that the distribution is flatter. Kurtosis ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿಕೊಂಡು there are 3 types of distributions. One is mesokurtic. Mesokurtic ಅಂದ್ರೆ it's a normally distributed curve. That means the value of the kurtosis is 3. You call that kind of distribution as mesokurtic distribution. And the second one is leptokurtic distribution. This distribution is pointier than the normal distribution. Andre kurtosis value will be greater than 3. And the third type of distribution will be platykurtic. That means the distribution is flatter than the normal distribution, means the value of kurtosis will be less than 3. Now you can see from this picture, this is the distribution graph or the curve for normal distribution. Now if you see this picture here, ಈ normal distribution in the curve and you ಮೇಲಿಂದ ಒಂದು ವೇಳೆ if you press the graph from above, you might get this kind of graph which is flattened. Peak ತುಂಬಾ ಈ end ತುಂಬಾ point ಆಗಿ ಇರುವುದಿಲ್ಲ. You will get a flattened curve. This kind of graph represents a platykurtic distribution. You say that, and we can say that here the more data concentration will be more around the mean, around the center point. Center point ನ ಸುತ್ತ data the concentration ಜಾಸ್ತಿ ಇರ್ತದೆ ಅಂತ ಅರ್ಥ. ಅದೇ ನಾವು ನಾರ್ಮಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಇದು ಪೀಕ್ ಅನ್ನು if you pull it above, you can get this kind of graph. ಈ ತರದ್ದು ಗ್ರಾಫ್ ಸಿಗ್ಬೋದು, ಅಂದ್ರೆ ತುಂಬಾ ಪಾಯಿಂಟ್ ಆಗಿರುವಂತಹ ಗ್ರಾಫ್. ಈ ತರದ್ದು ಗ್ರಾಫ್ leptokurtic distribution ಅನ್ನು represent ಮಾಡ್ತದೆ. As you can see here, the distribution of the data around the central value is less. Also, you can see that the tail of this kind of distribution is heavier compared to the normal distribution. And in this kind of platykurtic distribution, tail will be lighter, I can say. The concentration of data on the tail will be less. Next comes the difference between skewness and kurtosis. Skewness and it studies about the cluster of deviations above and below the measure of central tendency. Central tendency at mean in the central point in the data values ಹೇಗೆ deviate ಆಗಿದೆ ಅನ್ನೋದನ್ನು measure ಮಾಡುತ್ತದೆ. Kurtosis studies about the degree of concentration of data around the center. Central value ಸುತ್ತ data concentration ಜಾಸ್ತಿ ಇದೆಯಾ ಕಡಿಮೆ ಇದೆಯಾ ಅನ್ನೋದನ್ನು measure ಮಾಡೋದು kurtosis. Then skewness measures the symmetry, whether the data distribution is symmetric around about the central point or not. That measure is given by the skewness. And kurtosis measures the peakedness, whether the data distribution curve is pointier or flatter. That is given by the kurtosis. Then if skewness is 0, that means distribution is normal. But in case of kurtosis, kurtosis is 3 means it is normal distribution or it is mesokurtic distribution. Then when will be skewness positive? Skewness positive another meaning ಏನು? Skewness positive andre tail of the distribution curve is to the right of the central value or the mean, and the more data is concentrated after mean. Kurtosis is greater than 3 means it is leptokurtic. Skewness gemandre skewness negative irodi yavaga? Skewness negative andre tail of the distribution curve should be on the left side of the mean, and then more data is concentrated, dispersed, distributed after the mean, before the mean anta artha. Then kurtosis less than 3 idre adu platykurtic distribution annu represent ಮಾಡ್ತದೆ. Next, let us see how we can find the skewness in Excel. What we should do? First, we should collect the data to determine, and we should determine the mean and mode of the data. Then we should draw a line graph for the data. Then we should check whether the mean, how are the mean and median for the data. We should check whether the mean is less than median or mean is greater than median. If the mean is less than median, median ಗಿಂತ ಸಣ್ಣದಿದ್ರೆ, it represents a negatively skewed graph. If the mean is greater than median, then it represents a positively skewed graph. That conclusion we must write like this. See here, some data are considered and the mean is calculated, median also calculated. Then we have plotted a line graph for this data. Then we have marked the mean and the median. Then now if you see, the mean is less than the median. That means this data set is a negatively skewed data set. Same way, to calculate kurtosis, we have the formula in Excel, that is equal to kurt. Then within the bracket, you select the data range. If you use that data, you can calculate the kurtosis of that data range. Now let us quickly see how we can calculate in real kurtosis and skewness using Excel. So this is the data set we have considered. Now to calculate the skewness of this data set, first let us find out the mean for this data set. Then let us calculate the median. How do we calculate the mean? Equal to, then average, select the formula, then select the data range, close the bracket, then press enter. This is the mean. How do you find the median? Equal to, click median, then select the range, select the range. We have got the median. Now we should plot a line graph for this data set. Line graph, insert menu alli now graphs and insert ಮಾಡಬಹುದು. You should go to insert menu, then go to line graph. Now, let us plot the mean, mark the mean and median on the graph. Mean is 16.2. So let me 16.2 maybe around here. This is the mean. And the median is 17.5. That may be around this. Okay. Now, how are the mean and the median? You can see that here, mean is less than the median, right? Hence, you can say that the data set is negatively skewed. This is the conclusion that we must write. Same way to calculate the kurtosis. Let me consider a same data set. There is a formula equal to kurt. Double click on the formula, then select the data range, close the bracket, press enter. You are getting the value of kurtosis. So here the kurtosis is negative, and it is less than 3. That means it is a kurtic distribution. This is the conclusion that we should write. So this is how we can calculate skewness and kurtosis of a distribution of a data set using Excel.